So today's webinar is just on programming the VEX V5 EDR with the new VEXcode V5 blocks. It is officially released, and I'm going to show you real quick where you can find all the new software. But a little bit about me. My name is Alex Palowich. I've been working with VEX Robotics for a decent amount of time. So I have been working with the V5 ever since it came out. I was fortunate enough to get my hands on one of the beta units, and I absolutely love the V5 system. I think robotics has never been easier to understand. I think, there's certainly middle school and high school students who aren't as familiar with robotics, and VEX V5 takes them all the way from beginner all the way to advanced professional level robots. So I think it's an awesome system with a really high skill ceiling, but it's also really easy to understand, especially for older students that might be a little intimidated by all that goes into robotics. So let's get started. Where do we find the VEXcode V5 block software? So we go to the VEX Robotics website. So if we're at the main page, we click on the EDR, either link, and it's under the Products tab. We scroll down to VEXcode and Software, and it is going to show us this general splash page, just an overview of the VEXcodes, the different features and why they chose it. But if we click on the Download tab in the top right, it's going to show us all of our different options. So they have released both VEXcode, the blocks version, and the V5 text version. The text version is currently in a preview, so it's not fully fledged, realized yet, but it is a really great platform. So if you're interested in the V5 text, you can also check that out as well. But today we're going to be talking all about the V5 blocks, and that's an official release. If you're not sure whether your computer is going to be able to run it, go ahead and just click on this tab. That will show you all of the minimum required specs for any device that you are going to be running VEXcode on. They are still working on an iOS version, and that should be coming out pretty soon, along with their Android version as well. So you click whatever download link works for you, whether you're using Mac, Windows, or Chromebook, and then once you have it download, it's going to run just like a standalone program. But before we get into what VEXcode looks like, I did also want to share some helpful resources on the VEX Robotics website. So if you see right in the top right, they actually listed a direct link to their STEM labs. So if we click on STEM Labs, it's going to bring us to the general page. I already have a tab open here, but we just click on the EDR STEM Labs. And this is their whole new educational curriculum content, and it is all designed to be working with VEXcode. So just to show you real quick what it looks like when you get in there, it's a full unit plan, full lesson curriculum. It has teacher guides, everything like that, but then it also incorporates all of the VEXcode V5 blocks. And from the very basic drive forward and turn, it explains each block that you're using and why you're creating the program that you are. So it's really great, helpful resources. If you're working with your students, there's educational full projects, and you can have full access to it. And they did incorporate the new VEXcode. So if you're using the VEX Coding Studio, they have moved on all their educational curriculum, all their content has moved on to VEXcode. And I did just want to address VEX Coding Studio. That's a question I get kind of a lot. And they did really just want to update the VEX Coding Studio to 2 different platforms. And so when we open up the VEXcode V5 blocks, you can see that it's only focused on blocks. So it's a really beginner-friendly platform. All the students are going to be using the same VEXcode blocks, and when they are ready to switch to text, they're going to want to jump up to the more advanced version. But this should take them just about to the point where they're really ready to get into full-fledged advanced programming. So this is our open VEXcode V5 blocks. This is a brand new started project, nothing going on, and this is what you should see when you open up the project, or when you open up the program. So starting in the top left-hand side, there's a little globe icon, which is just the 3 major languages they have right now, and I'm sure they're working on more. But we should all be good with English. And then there's the file menu. So it's just project navigation, opening up your recent projects, saving your projects. But there's also this open examples tab, which I do want to draw some attention to. And this is an absolutely fantastic way just to see full completed programs. So they give you pretty much everything under the sun you would think of: sensors, driver commands, detecting certain things, drawing certain shapes or text objects to the brain. So they cover really everything. And at the top is just categories, and you can cycle through which one you're looking for. So say we wanted something to do with just the drivetrain and moving the drivetrain. Say we were really looking to get into sensors. We click on the sensing category, and this just separates all of the example programs into what you're looking for. And then even as you expand onto the more advanced topics like operators and variables, there are even some sample programs that explain these higher level topics like 2D lists, custom variables and how to use them, and things like that. In the templates section, the first category, templates, it's all just predetermined robot configurations. So if you're using one of the robots that Vex has designed, like the Clawbot or the Speedbot or something straight out of Vex's own designs, a lot of those configurations are already set here, and I'll show you what that's going to do in just a second. So continuing on across the top bar, we have our slot menu. So when you click on the slots, this selects which one of the 8 slots that the program is going to download to. And like I said, V5 has 8 slots that you can choose from, and you can save up to 8 different programs. So it's a little more expansive. If you click the text in the center, that's just naming your project. We don't have to worry about that right now, but if you were going to save your project, it's always a good habit to get into naming it something that's a little more descriptive of what you're doing. And then this not saved here just lets you know that your program will not be saved. You haven't saved it anywhere, and any changes you make won't be updated. Now the V5 is actually has a pretty sweet feature to it, and that's the wireless downloading through the V5 controller. So if you see up here, there's 2 icons. Now we can plug directly into the USB port on the brain, and we can update the firmware through VEXcode. We can view all of our settings for it. But if we wanted to, wirelessly program, you can actually plug the micro USB into the port on the V5 controller itself, and you can communicate to the robot directly through that. You can load programs, you can run different programs and change things all wirelessly. So it's a really great way to get out of the hassle of constantly unplugging and plugging in your USB cable into the brain. So for my demonstration today, when I show the webcam, I have the USB cable plugged into the controller directly. That way I don't have to pick up the robot and bring it back to the computer every time. So as we can see now, all of our options are currently grayed out, which means that nothing is connected. We can't download, run, or stop a program. When I click on the brain, I see no information. And so we're just going to turn on the robot real quick. Okay, so it just takes one quick second to boot up, but now we see that our controller has lit up green, which means we're plugged into the controller and it's communicating directly with our brain. So now when we click on the brain icon, it's lit up green, shows us the information, the specific name we're working with. We could update the firmware, but we would have to directly plug the USB cable from the computer into the brain. So if this is your first time using VEXcode, you want to make sure you're all up to date with everything. It is a good idea just to plug the brain directly into the computer for that first initial download. And if you did need to update firmware, it would just say install firmware right here. So it's really simple to do through VEXcode. And now that we are plugged in, we have a download, run, and stop button. So we can actually run, download, and stop our programs directly from this browser. So like I said, we're plugged in, or I have mine plugged into the V5 controller. I don't have to touch my V5 robot. It's where it needs to be, and I can download, run programs to where it currently is. And the top 2 buttons, they're not very important right off the bat, but the share feature just allows you to export your current code as a PDF picture. So if you're trying to share your code online or just show someone real quick a snapshot of it, the share feature will allow you to export a PDF of your current project. And it basically just saves whatever this code block is or whatever code blocks you have in the center console. In the feedback, that's just for Vex directly. If you're having an issue or there's a bug you come across, you can always just send them a message real quick, let them know what happened, and that way they know and they can log it and they can make sure it doesn't happen again. Like I said, these both of the VEXcode current versions are pretty new. They are full releases, but at the same time, they're always updating it and they're always fixing bugs. So if you ever come across something, know that it is a pretty new software, but they're more than happy to get on it and fix it pretty quickly. So while we're up in this top right-hand corner, I did just want to draw attention to the help block. So when you click on the question mark, it tells you to select a block. And now any block that we click on the left-hand side, it's going to give us a full rundown of the parameters it uses, how to use it, what kind of values and what different variables it can accept, and then just some examples of it. And this goes for every single block on the left-hand side. So if there's, you're scrolling through these when you're going to use VEXcode and there's maybe some blocks we don't get around to covering today or you're just curious about, definitely use the help function on the top right to just explain what each block is going to do specifically. Okay, so now we're all set. We kind of understood the basic layout of the top menu. So what's the very first step when we're making a VEXcode program is setting up our robot. So we click this little device icon right here, and this is our device configuration setup. So the very first thing we want to do is just add what devices our robot's working with. So the very first thing that comes to mind is going to be a motor. And actually, real quick before we get into device setup, so right now before we set up any devices, we are only working with the V5 brain. So it only knows that we have a V5 brain, and as you can see on the left, the only functions it will allow us to drag out correspond to the V5 brain. So before we even get started adding in motors and adding in the other devices we're working with, it's a really good idea just to try downloading that basic print hello program. So right over on the top left, we just want to click and drag on this purple block, print hello block. And now when you drag it over, you're going to see this kind of dark highlight and it's the outline of the block. So it should just snap right onto the top block, and that lets you know that they are attached to each other and that it's part of the code chain. And as we add more blocks, just the way that this block style or scratch style programming works, they're all attached to each other, and any block that you grab will be automatically attached to any block below it. So as you can see here, if you're trying to edit out a specific block, you would need to grab this whole chunk out and then grab the blocks beneath it and then just replace it like that. But let's try our very first program where we just dragged out this first print hello statement. We attached it to our when started block. I'm going to turn on my robot again, I think, just because it turned off after waiting so long. So just give me 1 second. So we just turn on the robot real quick. Now we see we have a green icon, lets us know we're connected once again, and we just hit download. And you can save your program in this step, but since this is just a very easy test program, I'm not going to worry about saving it. We can just hit cancel, and it will still download it to the slot that we have selected. So it's on slot 1. Now that we have it downloaded, I can go ahead and hit run. And just to save some time, this is what we should see on the V5 brain. We should just see the name of our program at the top, VEXcode project, since we didn't name it anything, and then it should just print hello to the very first line. So that lets you know that your first download was successful, you communicated successfully with your brain, and you can go ahead and follow the same process to download any other program. So we have our program downloaded. Now we want to, flesh out our robot and program what our robot actually has, which is motors, maybe sensors, whatever. We want to set that up. So we click on our device tab once again. We see that we have no devices set up. And so let's add a device. And the very first thing, the very most basic device is just a motor. Even a drivetrain, everything else is just made up of motors. So the very easy motor, we're going to start with port number 8. That's our arm motor. And we're just going to try to get our arm to lift up through a command. So by default, it's going to name the motor after the port it's assigned to, but I really like to get in the habit of giving them custom names. So now we know it's an arm motor, and you can also change the directions. And I really like this because it's an arm motor. So is it going forward and reverse? Well, no, it's going up and down, or it's raise and lower are the two directions. So you might get confused when you're going to lift up your arm, whether forward or reverse is going to make it go up or down. So I like to give these custom names as well. And if you're using any of the custom V5 gear cartridges, you can go ahead and switch your settings, and it actually shows the color that you're currently working with, which is exactly how a V5 motor looks. So it makes it really easy to keep track of which gear cartridges you're using. And you can also reverse directions. So if I find that, I name these two directions and lower is actually making the arm go up, I can just click reverse and it will just switch the two directions. Or I could just name them the opposite. Okay, so now we have an arm motor added as a device. And if you noticed on the left-hand side, it now populated this whole motion category. So now that we have a motor attached and configured as a device, it added all these different motor commands. So we can just spin the arm until it gets the next command. We can spin the arm, raise it for a certain amount of degrees. We can have it turn to a certain position. And then a couple other things, like we can just change the overall velocity. We can change how much torque it's applying to, whether it holds its position when it's done moving. And we can also set the arm motor timeout. And once again, I really like the help feature because say we were looking at this timeout and we're not quite sure what it means. Well, we can click the help block and it explains what a timeout means. And basically what it does is it cuts off the motor if it keeps trying to spin, but it can't spin anywhere, if it's hitting something. So after a timeout of 1 or 2 seconds, it's just going to tell the motor to stop applying power and to stop there because it's already timed out and it can't go any farther. But once again, the help block, just really great reminder of what each block is going to do and how to use it. And like I said, there's always going to be an example with each help statement, so that really helps you know like how you're going to use the specific block and what a program would look like with it. Okay, so let's get rid of our print hello statement, and by just clicking and dragging over to the left-hand side, we see a little red X, and you just let go, and it removes the blocks. So to delete blocks, just go ahead and drag them over to the left-hand side where you found them, and they should go away. So let's do a very first command, spin arm motor. We're going to raise it. Oh, and you can see there's a little bit of gap, so it's not fully attached. And now we have it attached to the when started block. We can switch it to turns. Because it is a 12-tooth gear going into, I think, like an 84 or something tooth gear, 90 degrees isn't going to be a lot of turns. So just for the sake of this demonstration, I'm going to make it raise for 1 turn of the motor at that small 12-tooth gear. So once again, we download. Not too worried about saving the program at this point, but we downloaded our program and we can now run it. And I'm just going to show my webcam real quick before I do this. So here's our robot. We downloaded our lift arm program and we're just going to click run on VEXcode Blocks. Awesome. So that was 1 full turn of the small gear that is attached to the motor. And that was our output. We ran it wirelessly from our controller, didn't have to move the robot, didn't have to touch the robot. And now when I hit stop, a little rough of a landing, but it just cancels the program and goes right back to its reverted starting position. Okay, so that was awesome. We got movement out of the robot, we mapped our motor, we got it to lift the arm up. Let's get a little more complicated. Let's get this robot to drive forward or, navigate a little bit. So we could go back on our device setup, and now we could add a left and a right motor separately and do the same thing and then just program them to turn together. But to save ourselves time, saves ourselves a little bit of hassle, we're going to use the drivetrain feature. Now the drivetrain feature, it already asks you what motor is on the left-hand side. So for the V5 Clawbot, it's going to be port 1. The right motor is going to be on port 10. And this just lets it know which motor is oriented where. So it knows that the right-hand motor needs to be reversed because it's flipped over compared to the left motor. So by setting the left and right-hand side, you don't have to worry about directions or reversing either motor. It takes care of that for you. And they do include options for a 3-wire gyro port. So if you did have a gyro hooked up to it and you wanted to get a really accurate output with your drivetrain, you can set that under the drivetrain itself, but I'm not going to worry about that for this demonstration. So when you don't select the gyro, it's going to take you to this Drivetrain Settings screen. So here you can set what kind of wheels you're using, the different diameters or just different types of wheels. You can also set the general width of your drive base. That lets it know how far it needs to turn to get an accurate 90-degree turn with your specific drivetrain. And you can also set whether you're using any sort of different gear ratio, either in the cartridges themselves or just through standard gear reduction or improvement. Clicking the down arrow or the up arrow just sets which what the orientation is. So if your drivetrain is driving backwards, you actually want it to make the other way forward orientation, you can just click this downward arrow and it kind of just reverses that around for you. But for a standard drivetrain, we shouldn't have to mess with any settings. We should be able to leave it as the upward facing arrow. So now we're done. We have all our drivetrain, we're configured, everything looks good. Now we have a whole drivetrain category of commands. Very similar to the spin motor commands, but they're just very generic statements like drive or turn. And these are predetermined statements that work for the drivetrain. So it knows that when it needs to drive forward, it needs to apply the same direction to the left motor and then the opposite direction to the right motor to go forward with the whole drivetrain. And because we used our settings as far as the wheel diameters, as far as the wheelbase width, we get pretty accurate outputs. So because we set all of those settings and it knows exactly what kind of drivetrain we have, we can say something like drive forward for 12 inches, and it should get a pretty decently accurate output because we were so accurate with setting up our drivetrain. So we'll drive forward for 12 inches, turn right for 90 degrees. So now we have these two blocks, and these correspond to the drivetrain. So if we wanted to spin the motor after this, we could just go back up to our motion commands, and then we would just want to drag out a specific arm motor command. But let's just test out this little drivetrain 2 steps that we planned out right here, just so you can see how the drivetrain works together. When you program and when you set up the drivetrain as a device, it makes driving forward a little bit simpler. You don't have to do 2 commands for each simple action. So once again, download our program. And then when we're ready, we're going to go ahead and hit run. It's pretty action-packed. So we noticed that it didn't do an exactly perfect 90-degree turn. And this is because we didn't use the gyro. So we got an almost accurate turn. All of our settings weren't perfect. Little things like the fact that we're using Omni wheels with the Clawbot and other factors do affect the general output. But by setting the width and the tire size, you get pretty close to an accurate turn. But as always, without any specific sensors and accurate readings, a little bit of turn scrub and a little bit of drifting like that is going to happen. So now we have our basic robot set up. We could add in the other motor just for the claw. So the claw motor is on port 3. And I'm just going to do this real quick to show you how to set up the overall driver control for a basic Clawbot. So we have our claw motor. Once again, I'd like to rename the directions. So instead of forward and reverse, we'll call it open and close. And so now we have our full robot configured. We have our drivetrain with our 2 left and right hand motors, and we have our arm motor as well as our claw motor. So now our Clawbot's fully configured. We have all those steps taken care of. Let's go ahead, we want to drive it. We want to, write our own custom program. We want to be able to, drive it how we would like to control it. So the easiest way to set up driver control is by adding the controller as a device. And now once we have the controller as a device, this unlocks a lot of new options for programming. So I won't worry about mapping the buttons just yet, and I'll show you why. So if we didn't choose to map the buttons in the traditional sense of device setup, we can go over to events, and we can use these controller buttons to trigger any sort of events. So even in autonomous, or even if you weren't using driver control, you can still use driver controlled input to start certain parts of your program and stuff like that. So we can see here that just like we have our when started block that initiates the whole program, we actually have a whole bunch of other when events. So we can trigger events by pressing the screen brain, things like sending broadcast messages, and now that we have a controller, we can also use controller buttons to start certain programs. And if we go back up to our looks category, we also now have the controller as a text LCD screen. So before, where we were printing hello on the brain, we can now print it on the controller as well. And we could name the controller something else, and you can actually plug in 2 controllers. So if you're using a partner joystick, you can also add in a second controller, controller 2, and then you can print things to each different controller, and you can program different controllers to have different effects on the robot. So there's a ton you can do with controllers, and it does open up a lot of different functionalities with V5 programming, just even with the LCD screen and the feedback you can get to the controller. The controller also can play a rumble, so you can have the controller shake or vibrate when a certain action happens or something like that. So there's a lot of cool uses I think that teams are going to find for this, and I'm really excited to see where students' brains go with that. So besides all the cool text printing and event triggering and stuff, how do we program the controller? So without doing any code blocks, without dragging anything out, we can fully set up driver control to drive around our robot. So when we go back to the controller setup, we see all these blank buttons, and it tells us to select and set the actions. Well, since we have our drivetrain mapped out already, it's automatically going to go to the joystick, sorry. When we click once on the joystick, it's left-hand drive. We click again on the joysticks, right-hand drive. That means that the right stick controls left, right, forward, and back. We click on it again. We can have split drive or arcade drive. I'm not sure what that's called at this point. And then tank drive is the last one, where the 2 left and right-hand sides control the left and right sides of the drivetrain independently. And this is probably the most common one. If you're using the standard Clawbot driver control, this is how they have it set up. So if you were looking to just get back into that, and you wanted to manually set up driver control, you would add a controller and you would set your drive behavior. Or say you didn't like that and you wanted it to be just on the left-hand stick, well, you could absolutely come in here and modify that. And now that we have our drive behavior set up, we can go ahead and map out the other buttons. So we can click any buttons on the front face and we can map our motors to them. So we can do the Y or the X and B buttons, we can do the front arrow buttons, or we could even put them to the bumpers on the front. And this is the default programming, but this just shows you that if you didn't like the way the controllers were set up, you can always go back and set it however you want with your custom settings. And if you don't like, the orientation between which one is closed and open or raised and lower, you can always click this blue swap arrow, and that just changes the 2 directions to your liking. Okay, so now we have our controller set up. We're all good to go there. And now our driver control is set up. And I did want to get into talking a little bit about competition use and why VEXcode V5 Blocks is one of my favorite updates to Vex and why I'm really glad they did it. So when we go back into the Events tab, we talked about how the when started is automatically triggered at the intro to every program, but we can also use other broadcast statements to start other chains. So, controller input after a certain amount of time has passed, or just, at the end of this statement, we could broadcast message 1, which is going to tell it to start this new chain. And this is a little bit of advanced programming topic when it comes to, sending different function calls and, different logic control. But the one really great thing about this is that they have when autonomous and when driver control statements already predetermined in VEXcode blocks. So for a lot of starting teams that are looking to get into competition, this was always kind of the big hang up, because they had to program in text, they had to use these elaborate function calls to autonomous and driver control, and a lot of teams it got really confusing. So the way they've kind of simplified this is just made them really simple event control blocks. So if I'm programming for competition, I can set up really easily. I can just use the help block, and it will explain what the autonomous how the autonomous functions work, how they are triggered, and same thing with the driver control. And it just explains a little bit about how they're used with the competition mode and the competition switch. And this has been a really big confusing factor, and autonomous is a huge part of VRC competition. So it's really great to see that Vex kind of took a more simplistic approach to this. And going back to the example programs very briefly, they do have a competition template right here. So if you go under the templates, competition template, they explain it and you can just automatically start a competition program, and there's even a tutorial that explains the competition templates as well. And before we go on to a little more advanced topics, the tutorial tab is definitely something I wanted to draw a little bit of attention to. I'm not sure if I touched on this before, but these are little embedded videos that explain just about every facet of VEXcode. So if you were coming back to this after this webinar and thinking, well, I didn't, really understand how he moved and dragged around the blocks and how that worked, well, you can click on that specific category on a tutorial video. It's a small little embedded video that can play as you're coding, and you can even blow it up just to watch it in full screen if you really wanted to focus on it. But you can also code along with it, and you can also download the video to watch it later on. Because, unfortunately, we really won't get the time to cover all these topics today. iDesign is going to be doing more future webinars on a lot of more advanced topics, but the tutorials are a really great way to understand some of these other facets of programming that we didn't get to cover today. So I went into this new competition template program and it deleted all of my devices. So, that's frustrating, man. But it actually makes it really easy, or VEXcode makes it really easy to get back to where we were working or to get back to our standard drivetrain setup. So I could either go into Open Recent and I could open one of the programs I was just working on if I had saved it, but we can also open up one of these examples. If I go under templates, all of these templates are just device configurations. So like I said before, we were just using a standard clawbot with a drivetrain. So I can choose that template and it automatically populates my drivetrain and my clawbot when I go back into the robot, or when I go back into a new program. So for students that are using standard clawbots, they can save themselves a little bit of time when they go into a new program, and they can just use the templates that are already pre-made by Vex for them. The one thing to watch out though for is when you add in this clawbot, it automatically assigns a gyro, and I don't think a gyro comes with the clawbot or the classroom kit, and I don't think most teams have them, so I always try to get rid of that and make sure that you're not using the gyro, because that can sometimes mess up your program if it is looking for that sensor that it doesn't have. So going back into the device setup, Vex still did include compatibility for all of their 3-wire ports. So that's another thing I wanted to mention real quick. If you click on this 3-wire devices, it brings you back to all of these legacy ports, even all the way up to servos, 393 motors, things like the rangefinder, the light sensor, the potentiometers, the LEDs. They're all still supported with Vex, and this is where you find them. Now, this is sort of unofficial confirmation, but Vex has announced that their V5, it was designed to handle a little more robust sensors and some advanced sensors. I know they do have a couple things planned out on the horizon, but at the moment they did want to do full backwards compatibility with all of their legacy sensors. So it's hard to say, that these sensors won't get updated or won't, get turned into V5 sensors at some point, but at the moment you're still going to be able to use every single sensor you're familiar with. And they did a really great job of incorporating that, and because sensors are great and a lot of teams are really used to the sensors, really like the sensors, and there's functionality you just can't get without them. And if you have questions on any of the sensors and how to implement them, once again I would invite you back to this examples. And if you go under sensing, they have an example program for just about every sensor. So potentiometers, using line tracking, using LEDs, quadrature encoders, all the way up to the vision sensor as well. And the vision sensor is one of the newest and coolest devices from Vex. And they do have a lot of great examples on that as well. So setting up with the drivetrain, setting up with the vision sensor, detecting objects, detecting color signatures and stuff like that. And then there's also tutorials on configuring the vision sensor and how to set it up and actually use it. So that's definitely one of the newer sensors that a lot of people aren't very familiar with. And as you get to that point with VEXcode, they have those examples there for you to look at and to look over. So a lot of people are very familiar with Scratch, but I just wanted to cover this topic real quick just in case anyone hasn't worked with Scratch before, and realize why everybody loves it so much. So one of the biggest things about Scratch is their color and their shape coding, and the way that the colors and the different shapes, the different where things fit, how they all work together. So Scratch was designed to be extremely visual, extremely easy to understand, and as you can see, even from an initial standpoint, all of these different categories of code blocks are color coded. So if you know that all of your purple statements are going to respond to visual effects or get something to print to the screen or some effect on the visual nature of the output. All of your blue statements, your drivetrain in motion, those correspond directly to motors. The only thing that's a little confusing is this really lightest blue, which is for sensing. Those are all for sensor commands. But they do a really awesome job of explaining it and showing it in the tutorials as well. But just to cover kind of how Scratch works, so when we drag out something like a loop statement, something like a forever loop, a repeat loop, it has this little area inside of it. It looks really small right now, but it will actually expand to whatever we're trying to add. So say we had 4 drive forward for 1 inch commands, and this is just a dumb example, but we can drag this entire block and nest it inside of the forever loop. And this is the genius nature of Scratch. This is how, visualization of control structures really heads home with students and anybody that's learning programming. It makes it super easy to understand. So we can see that this forever loop, it encompasses all of these drive commands, and this entire drive forward for 4 inches is nested inside of the forever loop. So it's going to keep doing that forever. And as we get more complicated in programming, we can really start to, get a little crazy with this. So we can have, an if and else statement that's nested inside of our forever loop, and then another if condition that is nested inside of the first if condition. So you can get pretty complex, I'm not even sure what the word is for it besides, it just makes me think of Inception. It's like there's so many codes within loops, within codes. But in terms of complexity and what you can do with VEXcode IQ blocks, it is astounding. It's a really high-level programming language that's really simple to understand. So let me get a little bit of this clutter out of the way here. And I talked a little bit before about how the shapes are so important, and I'll explain that real quick here. So we see for something like our if statement, it has this kind of hexagonal shape to it. And what that actually corresponds to is a condition. So anything that's in a hex shape is a conditional statement. So if we look through our sensing commands, something like a value or a variable that's reported back to the brain, like the battery voltage, that's not really a condition. The brain can't test that to see if that's true or false. So it has this round edges to it to let you know that it can go inside any statement that has a round variable with it. So if we wanted to drive forward for 1 inch, well, we could actually drive forward for whatever the battery current in amps is in inches. It's a really bad example, but you see how these shapes nest inside of each other. So any of these round variables, any of these round inputs, they fit right into any variable with a round shape to it. And you'll see it highlights when you drag it over it to let you know that it's going to snap right in. But we cannot put that in, say, a conditional statement because the shapes don't match. So for younger students or for anybody that's just getting into programming, the fact that they kind of, foolproof it, it's hard to mess up, it's hard to put the wrong value in the wrong spot. It just makes things that much simpler, and it really lets you understand what you're trying to do here. So I said before, a hexagonal is a condition statement. So we have some statements like, is the arm motor done? Is the arm motor still spinning? So we can drag that, and as you see, it highlights right over the shape to let you know that it will nestle right in there. And now we have a condition statement. Is our arm motor spinning? Then do this command, and if not, it will just move on. And so expanding from that, we have operators. So as we see, these round-edged operators do mathematical operations. So they would either like increase or just change the value slightly. And so we can have, a current value plus an arbitrary amount, or we can add 2 different sensor values together. and that makes an overall value statement, one of these round statements. So you can even nestle in values and conditions into each other. And in our operators tab, we also have these hexagonal conditions. So rather than changing the variable, we are comparing it. So we are saying here, if the battery current in amps is greater than 50, then we want to stop the motor. So we see we have this conditional statement that nestled right in there. It's asking for two round variables, so we were able to drag and drop the round variable shapes in there and use those. But we can even nest condition statements. So say we wanted to test two conditions. Well, we put one condition and another condition, and we can nestle that inside of our if statement. And so this is, getting a little ahead of ourselves definitely for starting out programming, but it just shows you the complexity and the high level of skill ceiling that Scratch does have. So it seems really simple, seems really rudimentary with its outward appearance, but what you can do with it is simply astounding. I've seen some really high level sensor filtering programs. I've seen PID loops created in Scratch. So it's pretty immense what teams and what students are able to do with it. And then just a couple last minute quality of life mentions when it comes to Scratch programming that I really like. So say I click and I'm dragging around this whole group of code blocks. I can right click, I can duplicate it. I can delete it as a chunk. But you can also, if I'm clicking and dragging around, I can hit Control C to copy, and then I can just Control V and paste it as many times as I want. And I can even Control Z and undo the code as well. So, as you get used to these keyboard shortcuts that a lot of students and programmers are familiar with, they are incorporated into Scratch as well. If I had a lot of statements, I can always right-click, collapse the blocks. So if you right-click anywhere outside of the code and hit Collapse Blocks, it will take that entire chunk and just condense it into one line. So it's still the exact same code with the exact same function, but it's just a little bit cleaner, a little bit easier to read. And a couple other things and tips for getting really organized code. If you right-click as well, you can always add a note. And so I could just type, this part of the code, does this and this. So I can just click and drag, a quick little note disclaimer next to any part of the code. And if you go down to the bottom, you can always also just drag in a comment statement. So the very last category is comments. You drag out this comment statement, and you can just type anything in here, and it will not be registered by the program. These are just comments directly for whoever's looking at the program and whoever's reviewing it, just so it makes a little more sense and they can understand what's going on. And the only category I didn't really get a chance to just talk about, and I did want to talk about, is the variables. So they support your custom Boolean variables. They support making custom normal variables, integers, floating variables, stuff like that. And you can also make 2D lists that you can iterate over and access different values from. So it's pretty complex. There's a lot you can do with making your own custom programs and custom functionalities that you specifically want. And if you weren't 100% solid on what custom variables are and how you use them, well, there's actually examples with the custom variables to show you how they're implemented, whether it's 2D lists and getting printed values to the screen, or whether it's using variables in programs. Well, okay. So before I was going to go on to other things, conditions, more advanced control statements, but it looks like we are just about out of time. I'm really sorry for going so long, so close to the wire. But I did just want to give everybody a minute to talk about any questions or any concerns they had with the webinar, or if anything seemed confusing or just any questions you want to get out now, feel free to let me know.
Alex, David was asking me about how to set up a drivetrain with 4 motors. And I mentioned that you could do up a little video or a little demo and send it to him. I don't know if anybody else is interested in that as well. That's getting a little advanced, but that's why we're here.
To be honest, I think at that point, Vex almost supports you just adding them all as 4 separate motors. I don't believe they've currently added a 4-motor option for drivetrains, but that's something I'll definitely ask with the RoboMatter guys and see if they're looking into it or what their stance is on it at least. Was it David was looking for that?
Yes.
Absolutely, yeah. I'll be happy to give you that answer. And like I said, I'll converse with RoboMatter and see their thoughts on it and whether that's something they plan on implementing or just an easier way to do that. Now, we will definitely get back to you with that information.
Thank you.
You're very welcome. Thank you so much for asking that question. I appreciate that.
I had a question. Can you convert the block to text?
Unfortunately, no. That is something they are definitely working on implementing, but at the moment they are separate files that don't coincide, unfortunately.
Okay, thank you.
Yeah, absolutely. But that's something that students really love to see when they can convert their blocks into text. And it's a really great way to get kids on that transition. So that's definitely something that they really want to see is cross compatibility between the 2 platforms, and it's on their list.
I had a second question. Do you have to download the 2, the block code and the text code separate, or is there? I thought I saw there was a download package that I did download a package in June that contained both.
So that was the VEXcode Studio. So
okay.
That was their original plan, and to be honest, they followed the exact same formulas for their block and their code text, or their text and their block versions, but they just found that incorporating them both in the same program made it a lot harder to get the updates that beginner users wanted and make the updates that advanced users wanted. So the separation was intentional just because they found so many issues with trying to house them all under one program. So as of now, yes, they're separate programs, unfortunately.
Okay, thank you.
You're very welcome. Thank you for asking. I appreciate that. And we will have recorded this webinar. It will be posted on YouTube. So if you ever want to look it over or just you had any questions about it, feel free to reach out to us, but we'll send you that link too very shortly. But thank you so much, everybody, for your time. I really appreciate everybody showing up today. I know it's 2:30 is kind of a rough time to get everybody. So I sincerely appreciate everybody's time and interests. And if you ever have questions, just let us know. We love talking robots, and we're always here to help. And we do have more webinars going on, as well as teacher training that we do offer. So we're definitely here to help you get started if there's any more advanced topics you wanted to go into, and things with like robot design, robot lifts, and drivetrains. But thank you so much for coming in today.
Thanks, Alex.
Thank you. Have a good night.
You as well. Thank you.